This is the one step that will make you competition ready. It is part of the define the problem phase of the engineering design process, where you list all of the criteria and constraints. Criteria and constraints are all of the requirements a team needs to know if they're going to solve an engineering problem like building a robot to compete in VEX. Criteria is what a team/robot needs to have. This could be as simple as needing to be able to reach a goal or cross a barrier. Constraints are what a team is limited to, meaning they have to stay within a height limit or they have to only use so many materials because it is all their program can afford. So why is it important to know your criteria and constraints? Understanding what a robot is limited to with the constraints makes sure that your brainstorms and developed ideas only include things that are possible for your team to use for building, while understanding criteria ensures that those essential details are included in your design. Our example of this is Turning Point. Turning Point was notorious for the expansion zone, an area dictated by tape where you are allowed to expand taller than 18 inches in height. This is a constraint because of how it limits the robot/team. Many of the criteria and constraints with a VEX game are actually in the game manual and online resources that VEX provides. An example would be the constraints that are often dealing with the number of motors a team can use, which is found here, or the maximum size that a team's robot is confined to, which is here. Things like this are found in that particular year's inspection checklist. Let's go through some examples of criteria. The criteria and constraints list for a team could include some of these ideas for the game change-up. One example of criteria in this game are that goals are high, so teams will need to be able to elevate the balls above the goal in order to score. Another example of criteria is that the balls will need to enter and exit the robot, so the robot has to be able to intake balls around the field as well as from the bottom of the goal, as well as extake the balls into the top of the goal.
This is why looking over the game manual is so important. By looking at all of the rules, by understanding the nuances behind each one, and fully analyzing absolutely every aspect of the game, you and your team will know exactly what to do. You will know what the competition will look like and how to face that in the most effective way possible. By developing your list of criteria and constraints directly from the rulebook, you know what your robot has to be able to do in order to fully and competitively compete in each year's game.
So to reiterate why we need to know our criteria and constraints, this step of the design process is often regrettably overlooked and then reminded of at competition. Whether it is breaking one of the game rules or missing a criteria that everyone else has, forgetting to properly dictate the team's criteria and constraints could be detrimental to their competitive performance. But if a team has a well thought out list of constraints alongside of what they know they have to have, a path towards a competitive and well designed robot is being paved. Thanks for watching.